There are places in the universe no spacecraft has ever reached. Questions no equation has ever fully answered. Worlds that spin the wrong way, storms that refuse to die, oceans hidden beneath ice, quietly waiting. Tonight isn't about answers. It's about the mysteries that remain. As you listen, you don't need to stay awake. You don't need to understand everything. Just let the unanswered questions drift past you, like distant stars slowly fading into sleep. Welcome back. Tonight, on Dreamy Science Stories, we'll drift gently toward the edges of what science still doesn't know, floating through some of the deepest mysteries it has to offer. For all the answers we've uncovered, the universe remains filled with open questions, not loud mysteries, not urgent ones, but quiet gaps in our understanding that invite curiosity rather than demand solutions. Some of these mysteries stretch across deep space, through galaxies and black holes. Others rest much closer, in the rhythms of time, the structure of matter, and the simple fact that anything exists at all. Science, after all, is not a finished book. It is a story still unfolding, and every unanswered question is not a failure, but a doorway. So let your thoughts slow. Let these mysteries pass through your mind like distant constellations. You don't need to solve them, you only need to listen. We still don't know why the universe exists in the first place. It sounds like the simplest question imaginable. Why is there something rather than nothing? Physics is very good at describing how the universe behaves once it exists. Cosmology can trace its history back nearly to the beginning, but the reason for existence itself remains beyond explanation. Quantum theory tells us that even empty space is never truly empty. Particles appear and vanish in restless flickers. Some scientists wonder if the universe itself emerged in the same quiet way, not from nothing, but from a state where nothing was unstable. Others imagine that our universe may be just one of many, a single bubble in a vast multiverse, each with its own rules. But even then, the question only deepens. Why does the multiverse exist? No experiment can reach that. No telescope can peer behind existence itself. Every star, every atom, every breath rests on a foundation we cannot explain. And that mystery remains, calm and unresolved. We also don't know what truly sparked the beginning of everything. We call it the Big Bang, a moment nearly 14 billion years ago when space itself began to expand. We can describe what happened fractions of a second afterward. We can measure the universe's age, its growth, its fading heat. But the cause of that first moment is hidden. Some theories suggest the universe emerged from a quantum fluctuation, a brief tremor that became space and time. Others imagine cycles. Universes expanding, collapsing, and beginning again in endless rhythm. And then there is time itself. If time began with the universe, asking what came before may not even make sense. Our instruments show us the universe as a newborn, but the very first spark remains unseen. The match that lit the cosmos is still in the dark. Time itself carries another mystery. It always moves forward, never back. We remember the past, not the future. Heat spreads, glasses shatter, moments slip away. Yet at the deepest level, the laws of physics do not insist on this direction. Their equations work just as well backward as forward. So why does time flow only one way? Scientists point to entropy, the slow drift from order to disorder. But that only leads to another question. Why did the universe begin in such an ordered state at all? Perhaps time's arrow emerges from how information spreads or from the expansion of space itself. We don't yet know. Time carries us forward every second, yet its direction remains unexplained. Most of the universe is made of something invisible. When astronomers watch galaxies spin, they move too fast to be held together by the matter we can see. Something unseen must be there holding galaxies in place. We call it dark matter. It doesn't shine. It doesn't absorb light. It passes through ordinary matter almost untouched. And yet its gravity shapes the universe. It binds galaxies, bends starlight, and sculpts the cosmic web. What it is remains unknown. Scientists have searched for decades deep underground. In space. In particle detectors waiting patiently for a single signal. So far, silence. 5 times more abundant than everything we can see, dark matter remains one of the universe's greatest hidden presences. Then there is the force pushing everything apart. The universe is expanding but not slowing down. It's accelerating. Something woven into space itself is driving galaxies away from each other faster and faster. We call it dark energy not because it is dark, but because we don't understand it. It makes up most of the universe, yet we don't know its nature. It could be a constant energy of empty space, or a new field, or a sign that gravity itself behaves differently on cosmic scales. What makes it unsettling is what it means for the future. Galaxies drifting apart, stars growing isolated, space growing colder and emptier. The unseen force shaping the universe's fate remains unnamed, undefined, and powerful. Even the laws of physics themselves feel strangely precise. If gravity were slightly stronger, stars would burn too quickly. If weaker, galaxies might never form. If other forces shifted by the smallest amount, atoms would not exist. This delicate balance is known as fine-tuning. Why do the laws of nature have exactly the values they do? Some say coincidence. Some say countless universes exist, and we simply inhabit one that allows life. Others believe a deeper rule waits to be discovered. For now, the question remains open. The universe seems improbably suited for existence, and no one knows why. We don't know the true size or shape of the universe. What we can observe is vast, but limited by time and light. Beyond that horizon, reality continues unseen. Perhaps space stretches endlessly, perhaps it curves back on itself. The patterns of ancient light hint at answers, but do not yet reveal them. The cosmos may be infinite or finite without edges. Either way, its true form remains just beyond our reach. Beyond what we can see lies what we can never observe. Light from those regions will never reach us. Signals can never cross that boundary. The unobservable universe exists, silent and unreachable. It may look much like our own, or it may be utterly different. Our visible cosmos may be only a small island in something far larger. The rest remains unknown. Not because it is hidden, but because the universe itself places a limit on what can be known. Some theories suggest there are other universes. A multiverse of realities, each with its own laws. The idea arises naturally in modern physics, but it may forever remain untestable. No signal can cross from one universe to another, no observation can confirm it. Which leaves us with a question science may never answer. Is reality larger than our universe? Or is this all there is? The possibility remains, quiet and unresolved. And beneath it all, space and time themselves may be made of something deeper. Einstein showed us they can bend and stretch, but at the smallest scales, gravity and quantum mechanics no longer agree. The true nature of space-time remains unknown. Perhaps space and time are not fundamental at all. Perhaps they emerge from rules we haven't yet discovered. The universe may be built on principles still waiting to be understood. And so we arrive where we began, surrounded by mystery. Not as a failure of science, but as its invitation. These unanswered questions remind us that we are still explorers, drifting through a reality far larger than our understanding. And for now, that is enough. Let the questions fade. Let the mind soften. You don't need answers tonight. Just rest inside the wonder. Space and time feel smooth and continuous in Einstein's universe, a calm fabric, stretching gently beneath stars and galaxies. But when we look closer, quantum theory tells a very different story. At the smallest scales, reality flickers. It jumps. It hesitates. Instead of smoothness, there is grain. Instead of certainty, probability. Bringing these two views together has become one of science's greatest challenges. Some physicists now wonder if space and time are not fundamental at all. Perhaps they emerge from something deeper, a hidden structure made of quantum information, patterns of entanglement weaving geometry into existence. In this picture, space-time is only the surface, and beneath it lies a quieter, more basic reality we cannot yet see. Some even question whether time itself truly exists. Perhaps it is not a river flowing forward, but an illusion created by deeper processes. If that is true, then our most basic intuition about reality may be wrong. Space and time feel like the stage on which the universe unfolds, but the stage itself may be part of the performance. What it truly is remains unknown. In the quantum world, a single particle can seem to be in more than one place at once. According to quantum mechanics, particles do not have definite positions until they are measured. Instead, they exist as possibilities, a soft cloud of probabilities spread across space. An electron can pass through two slits at the same time, interfering with itself like a wave on water. Only when we look does the particle appear to choose a location. This is not speculation. Experiments have confirmed it again and again, not only with electrons, but with molecules far larger than we once thought possible. And yet, no one truly understands what it means. Is the particle really in two places at once? Or is superposition simply a reflection of what we do not know? Some interpretations suggest that reality splits. One outcome here, another elsewhere. Others suggest that reality itself remains undefined until it is observed. Whatever the truth, the idea that a single particle can exist in overlapping possibilities remains one of the strangest features of nature. Sometimes, particles remain connected no matter how far apart they drift. This is called entanglement. When two particles become entangled, their properties are linked. Measure one, and the other responds instantly, even across vast distances. Einstein found this deeply unsettling. He called it spooky action at a distance. Nothing should travel faster than light, and yet, entanglement appears to ignore distance entirely. Experiments have confirmed it with photons, electrons, and even small collections of atoms, separated by kilometers, still perfectly correlated. No signal seems to pass between them, and yet the connection remains. Some physicists believe this means reality is fundamentally non-local, that the universe is more deeply connected than space and time suggest. Others think entanglement points to hidden structures or undiscovered rules, or that information itself may be the foundation of reality. We already use entanglement in technology, but we still cannot explain why it works. Across the universe, particles whisper to each other, and we do not yet know how. Even observation itself seems to change reality. In the famous double-slit experiment, particles behave like waves when unobserved. They spread, they interfere. But the moment we measure them, the wave disappears. The particle behaves like a particle. The outcome changes simply because we looked. Why should that be? Some say the wave function collapses. But what causes the collapse? A machine, a human mind, or something else entirely? Other interpretations say all outcomes happen, each measurement splitting reality into branches. Some suggest that particles become definite only when information becomes irreversible. None of these explanations are complete. What we do know is that the boundary between observer and observed is not as clear as we once believed. The universe seems to respond to attention, and no one knows why. Gravity governs the cosmos, yet it is astonishingly weak. It holds planets in orbit. It shapes galaxies. It bends light itself. And still, compared to other forces, it is feeble. A small magnet can lift metal against the pull of the entire Earth. Why should gravity be so different? Physicists have searched for answers for decades. Some propose hidden dimensions where gravity leaks away. Others suspect unknown physics masks its true strength. Despite all our success in understanding gravity's effects, its weakness remains unexplained. And yet, this imbalance is essential. Without it, stars would not shine as they do, galaxies would not form. The gentleness of gravity is a quiet mystery that makes the universe possible. Our two most successful theories refuse to merge. General relativity describes the large-scale universe with extraordinary precision. Quantum mechanics governs the microscopic world with equal success. Each works flawlessly on its own. Together, they break. Inside black holes date the birth of the universe. Their equations collapse into infinities. Physicists have searched for a unifying theory for decades. String theory, loop, quantum gravity, elegant ideas, but unconfirmed. Without such a theory, we cannot fully understand the beginning of everything or the true nature of space-time itself. Both theories are correct, and yet together, they fail. That contradiction remains one of the deepest puzzles in science. The center of a black hole hides a mystery we cannot reach. According to our equations, matter collapses into a singularity. A point of infinite density, infinite curvature. But infinity often signals the failure of our math. Is the singularity real, or is it a placeholder for physics we do not yet understand? Some believe a deeper theory will replace it with something finite. A loop, a core, a new structure beyond our imagination. The event horizon seals the interior away completely. No information escapes. For now, the heart of a black hole remains unknowable. A region where certainty ends. Singularities appear elsewhere as well. The Big Bang itself may have begun as one. Places where time and space lose meaning, where our equations stop working. Many physicists believe singularities are not true features of reality but signs that our theories are incomplete. Beyond them, a deeper description must exist. Until then, singularities remain the edges of understanding where knowledge fades into mystery. What happens to information inside a black hole? According to quantum mechanics, information should never be destroyed. Yet black holes seem to swallow it completely. Hawking showed that black holes can slowly evaporate. That if they disappear entirely, what happens to what fell inside? This question is known as the black hole information paradox. Some believe the information is stored on the event horizon. Others think it leaks out encoded in Hawking radiation. Some suggest our understanding of quantum mechanics itself must change. The answer remains unknown. And yet, it may hold the key to uniting gravity and quantum theory. Hawking radiation itself has never been observed. It is predicted that it is mathematically elegant, but it is faint beyond current detection. If it exists, black holes are not eternal. They glow softly, they age, they fade. This idea links gravity, quantum physics, and thermodynamics in a profound way. Laboratory experiments have created analogues, hints, echoes. But direct evidence remains elusive. If Hawking radiation is real, it will reshape our understanding of black holes. That if not, something even stranger must be happening. Some theories suggest black holes may be more than cosmic endings. The mathematics allows for wormholes, tunnels through space-time. Perhaps black holes connect distant regions of the universe or even other universes entirely. Most physicists remain cautious. Such passages may be unstable or impossible. And yet the possibility remains. Black holes may not only destroy, they may transform. For now, their secrets remain sealed. Even the first stars remain partly hidden from us. After the Big Bang, the universe was dark, simple, filled only with hydrogen and helium. At some point, the first stars ignited, ending the cosmic dark ages. These stars were enormous, short-lived, violent. They forged the first heavy elements, they shaped everything that followed. But we have never seen one. They lived fast and died young, leaving only subtle traces behind. Astronomers search ancient stars for chemical fingerprints, quiet clues left behind by those first brilliant fires. The universe remembers, even when direct evidence is gone. And so, the story continues. The James Webb Space Telescope may one day catch a glimpse of their fading glow, but for now, the precise process that ignited the very first stars remains unknown. The universe's earliest lights are still wrapped in darkness. Some galaxies seem to have grown giants far too quickly. At the center of almost every galaxy sits a supermassive black hole millions, billions of times heavier than our Sun. We understand how black holes grow. They feed, they merge, they swallow what comes too close. But when astronomers look deep into the early universe, they find something unsettling: black holes that are already enormous, less than 1 billion years after the Big Bang. According to our models, there simply wasn't enough time. So how did they form? Perhaps they collapsed directly from massive primordial clouds, skipping the smaller stages entirely. Perhaps the first stars were far larger than we imagine, leaving behind oversized black hole seeds, or perhaps there is a growth mechanism we have not yet discovered. These ancient giants challenge everything we think we know about galaxy formation, solve their mystery, and we may finally understand how galaxies themselves were born. Until then, they remain cosmic contradictions: too big, too early, too quiet. No one truly knows why so many galaxies become spirals. When we picture a galaxy, we often imagine graceful arms sweeping outward like a cosmic pinwheel. Our own Milky Way is one of them. But why do these spirals form at all? One idea suggests they are not permanent structures. Instead, they are density waves, like traffic jams in space, where stars slow and bunch as they pass through invisible patterns. Another theory points to gravity's long reach. Galaxies tugging on one another, encounters that twist stars into curved arms. Simulations can produce spirals, but not reliably, not completely. Spiral galaxies are common, and yet their exact origin remains unsettled. When you look up and see the Milky Way stretched across the sky, you are looking from inside one of astronomy's unanswered questions. Sometimes the universe speaks in flashes too brief to explain. In 2007, astronomers detected a burst of radio energy lasting only milliseconds. Since then, hundreds more have appeared. Fast radio bursts. Each one releases as much energy as the sun emits in an entire year, compressed into a blink. Some repeat, others never return. Magnetars may explain a few, collapsing stars or merging objects may explain others, but no single cause fits them all. They arrive from billions of light years away, distorted by the matter they pass through. They may even help us map the invisible universe. But their true origin remains uncertain. Every so often, the cosmos shouts across the void that we hear it, that we measure it, and still, we don't know who is calling. Some stars keep time better than our finest clocks. Pulsars are neutron stars, the crushed remnants of massive suns. They spin rapidly, sweeping beams of radiation through space like cosmic lighthouses. When they were first discovered, their precision was so perfect that scientists briefly wondered if they were artificial. They are not. And yet their regularity is astonishing. Some rotate hundreds of times per second without drifting, without slowing. How can something so extreme remain so stable? Their density, their magnetic fields, their internal structure. We understand parts of the answer, but not all of it. Sometimes pulsars glitch, sudden changes in rotation that hint at strange physics deep inside, where matter behaves unlike anything on Earth. They are natural clocks, and still, they keep secrets. Magnetars unleash bursts of energy we barely understand. A magnetar is a neutron star with a magnetic field beyond imagination, trillions of times stronger than Earth's. These fields twist and strain the star's crust until something gives. In a single second, a magnetar can release more energy than the sun produces in thousands of years. We see them as intense flashes of X-rays and gamma rays. But what triggers these eruptions? Starquakes, sudden shifts in magnetic structure, a violent rearrangement deep within? Some fast radio bursts may even come from magnetars, but the full picture remains incomplete. They are rare, but their power is overwhelming. Quiet reminders that the universe still hides engines we do not fully understand. High-energy particles constantly rain down on Earth. Cosmic rays arrive every second. Most are harmless, some are extraordinary. The most powerful carry the energy of a fast baseball packed into a single particle. No known process should be able to accelerate them that much. They may come from active galaxies, from supermassive black holes, or from something entirely unknown. As they strike our atmosphere, they create showers of particles we can detect, but magnetic fields bend their paths, erasing their origins. They reach us, but their source remains hidden. Somewhere in the universe, nature runs particle accelerators beyond anything we can build. Between galaxies lie vast regions of near-nothingness. Cosmic voids stretch for hundreds of millions of light years, almost empty. Simulations suggest gravity naturally pulls matter into filaments, leaving gaps behind, but the largest voids are bigger than expected. Too big? Do they hint at new physics, at the influence of dark energy, or are they simply rare extremes? Voids affect how light travels across the cosmos. They may even help us understand the universe's expansion. For now, they remain unexplained. Looking into a cosmic void is like staring into nothingness on the grandest scale imaginable. The universe had a beginning, but will it have an end? One possibility is endless expansion. Stars burn out, galaxies fade, everything cools into darkness. Another is collapse, a reversal pulling everything back together. Or perhaps a big rip, where dark energy grows so strong it tears apart galaxies, stars, and even atoms. Which future awaits us depends on dark energy, and we still do not know what it is. For now, the fate of everything remains unwritten. Something triggered cosmic inflation. In the universe's first fraction of a second, space itself expanded at an unimaginable rate. Inflation explains why the universe looks smooth, why tiny fluctuations grew into galaxies. But what caused it? A mysterious energy field, a quantum feature of space-time itself? We see its fingerprints in the cosmic microwave background, but the engine behind it remains hidden. The universe grew explosively, and we still don't know why. Life on Earth began, but how? More than 3 billion years ago, chemistry crossed a threshold and became biology. We know life appeared early, but the path it took remains unclear. Perhaps RNA formed first, carrying information before DNA existed. Perhaps life began near hydrothermal vents, fueled by heat and minerals. Perhaps its ingredients arrived from space. We can create building blocks in laboratories, but not life itself. Whether life is rare or inevitable remains unknown. Even where life began is uncertain. Deep oceans offer stability and energy. Shallow pools offer concentration and cycles. Both environments could have nurtured the first chemistry, both present challenges. Until clearer evidence appears, the birthplace of life remains hidden in ancient rocks long transformed. And finally, the first living cell. Life is more than molecules. It is organization. Membranes, energy flow, information. How did chemistry assemble itself into a self-sustaining cell? Perhaps simple fatty bubbles formed naturally, trapping reactions inside. Perhaps complexity grew step by step, until something crossed a line. We don't know. The moment matter first learned to maintain itself remains one of science's deepest mysteries. And so, the questions continue. Experiments show that simple membranes can form on their own when conditions are right, tiny bubbles, separating an inside from an outside. A beginning. But what no experiment has yet explained is the next step. How did these fragile compartments turn into something alive? Somewhere between drifting chemistry and the first organized cell, a threshold was crossed. Matter began to maintain itself. To copy itself. To persist. We don't know how that leap happened, and until we do, the true beginning of life remains hidden. Life chose a very specific language. DNA. Every organism on Earth, from bacteria to blue whales, stores its instructions in the same molecule. A double helix. Elegant, consistent. But chemistry allows many possibilities. Information could be stored in other ways. RNA is simpler. It may have come first, and yet, at some point, DNA took over. Why this molecule? Why this exact shape? DNA is stable. It copies with remarkable accuracy. It carries vast amounts of information. But we don't know whether its structure was inevitable or accidental. Was the double helix the only solution nature could arrive at, or just the one that happened to work? Its universality suggests efficiency, but its origin remains unexplained. Life made a choice, and we still don't know why. Viruses exist on the edge of life. They are not alive in the usual sense. They cannot reproduce alone. They borrow the machinery of cells. And yet they evolve, they adapt, they shape the history of life. Where did they come from? Some may be remnants of an ancient RNA world, survivors from before cells fully formed. Others may be fragments of genetic material that escaped from cells and learned to copy themselves. Some may have once been living organisms that became stripped down to the bare minimum. Perhaps viruses arose more than once. In more than one way. What is clear is that they are ancient and powerful. They may have helped drive evolution itself, transferring genes, reshaping genomes. Viruses blur the boundary between life and non-life, and their beginnings remain unresolved. In the early Earth, chemistry was everywhere. Molecules formed in oceans. In volcanic pools. In lightning-filled skies. Chains grew longer, structures grew more complex. And yet, only a tiny fraction crossed the line into life. Why these molecules? Why not the countless others? What property allowed some chemistry to begin copying itself, to persist? Was life inevitable once the ingredients were present, or was it a rare accident, dependent on chance? We can create many of life's building blocks in laboratories, but we still cannot create a self-sustaining, evolving system. The gap between chemistry and biology remains vast. And within that gap lies a profound question. If life is inevitable, the universe may be full of it. If it was a fluke, we may be alone. Earth is the only living world we know. With billions of stars and countless planets, that feels unlikely, and yet the silence continues. We have found thousands of exoplanets. Some lie in habitable zones, some may hold liquid water. Organic molecules are common in space. Mars once had rivers. Europa and Enceladus hide oceans beneath ice. The ingredients appear plentiful. And still, no clear sign of life. No signals. No microbes. No fossils. Life may be common but quiet or rare beyond imagination. Until we find even the simplest alien organism, the question remains open. All life we know shares the same chemistry. Carbon, water, DNA, proteins. But must life always look like this? Could silicon form the backbone of life elsewhere? Could ammonia replace water? Could organisms thrive in methane seas? Some even imagine life based on plasma, magnetic fields, or information itself. Our definitions are shaped by a single example: Earth. The universe may be far more inventive than we are. If we ever meet alien life, it may challenge what we mean by alive. Thousands of planets orbit distant stars, but how many are truly habitable? Distance alone is not enough. Planets need atmospheres, magnetic fields, stability over billions of years. Some are scorched, some are frozen, some may be stripped bare by radiation. Moons may be habitable too, but we cannot yet see them clearly. Habitable worlds may be common or rare jewels. We do not yet know. And so the oldest question remains: are we alone? Despite the vastness of the universe, we have no answer. We listened, we searched, we analyzed distant atmospheres. So far, only silence. Perhaps life is common, but intelligence is brief. Perhaps life itself is rare. Perhaps it surrounds us but remains hidden. Until evidence appears, the question remains unanswered. Consciousness may be the deepest mystery of all. Thoughts, memories, awareness. They arise from the brain. We can measure signals. We can turn awareness off. But none of this explains why there is experience at all. Why does activity in neurons feel like something? A scan can show visual activity, but not the color of a sunset as you experience it. We have theories, information integration, neural patterns, even consciousness as a fundamental property of reality. But none explain the leap from matter to mind. Consciousness is ordinary. You are experiencing it now. And yet, it remains unexplained. Dreams fill our nights. Worlds appear, scenes unfold, then vanish. Why do we dream? Perhaps to process memory, perhaps to regulate emotion, perhaps they are simply the brain speaking to itself. And yet dreams can frighten us, move us, inspire us. Some problems are solved in sleep. Some ideas arrive unbidden. We know the brain is active, especially during dreaming sleep. But the purpose remains unclear. Dreams are familiar and mysterious. Time itself bends inside the mind. Moments of fear stretch endlessly. Hours of joy disappear. Clock time is steady, but experience is elastic. Emotions seem to change the speed of time. Novelty stretches it, routine compresses it. Childhood feels long. Adulthood slips by. We have ideas, but no full explanation. Time flows differently in the mind, and we do not yet know why. Your memories live inside you. Every moment you've ever lived is stored somewhere, not as files, but as patterns. The brain reconstructs memories each time you recall them, sometimes changing them, sometimes inventing details. Why do some memories last forever? Why do others fade? Why can a smell unlock a scene from decades ago? We see fragments of the process, but not the whole mechanism. Memory makes you who you are, and its workings remain hidden. Emotions shape everything. Fear, joy, anger, sadness. They involve the brain and the body, heart rate, breath, tension. Some emotions may be ancient survival tools. Others may be constructed by interpretation and memory. We know which brain regions are involved, but there is no single center. Emotion arises from networks, from history, from context. They feel immediate, but their origins are complex and still not fully understood. Music can ripple through the body and raise goosebumps without warning. A scent can pull you backward in time, opening a door to a memory you didn't know you still carried. Often, we feel something before we understand it. Emotions guide us quietly. They shape our choices, sometimes more strongly than logic ever could, and yet, how they arise, how they flood the body and color the mind, remains deeply mysterious. They are intimate, personal, and still largely unexplained. Creativity arrives without a map. An artist faces an empty canvas. A writer waits before a blank page. A scientist circles an unsolved question. Nothing happens, minutes stretch into hours. And then, suddenly, something appears, an idea clear, alive. Where did it come from? Some say creativity is the brain recombining old pieces into something new. Others believe it emerges when the conscious mind loosens its grip, allowing the subconscious to work quietly in the background. History is filled with discoveries born not at desks, but in dreams, showers, and silent walks. Brain scans show different networks switching on, some generating ideas, others evaluating them. But none of this explains the moment itself, why inspiration arrives all at once, why it feels like a spark rather than a gradual build. Creativity shapes art, science, and progress, yet the place it comes from remains hidden. A leap from nothing into something we still cannot trace. Sometimes the present feels strangely familiar. You enter a place you have never been, yet it feels known as if you have already lived this moment. This is déjà vu. Scientists suggest it may be a glitch in memory, a false signal of familiarity without a true source. Perhaps one part of the brain processes an experience a fraction of a second before another, making the moment feel repeated. Others think similarities to forgotten experiences confuse the mind. What makes déjà vu unsettling is its intensity. For a brief instant, reality feels doubled, both new and remembered. Almost everyone experiences it, and no one can predict when it will come. It reminds us that perception is fragile and that the brain sometimes bends reality in ways we do not yet understand. Belief alone can change the body. A pill with no medicine. A treatment with no active ingredient. And yet, pain eases, symptoms soften. This is the placebo effect. Expectation triggers real changes in the brain. Natural painkillers are released, chemistry shifts, the immune system responds. Strangely, placebos can work even when people know they are taking one. The ritual, the attention, the belief, all seem to unlock hidden healing pathways. Why some people respond strongly while others do not remains unknown. The placebo effect blurs the boundary between mind and body, showing that belief itself can sometimes heal. Every night, we surrender to sleep. Awareness fades, dreams begin. But why do we sleep at all? Sleep is dangerous in the wild. A sleeping creature is vulnerable, and yet, every species sleeps in some form. That suggests sleep is essential, but essential for what? Some believe sleep strengthens memory. Others say it clears waste from the brain. That it may regulate emotions, restore energy, and rebalance neural connections. No single explanation fits everything we observe. Dolphins sleep with half their brain at a time. Some birds sleep while flying. Others need very little sleep at all. What we do know is this: without sleep, minds and bodies unravel. Why we spend a third of our lives unconscious remains a mystery. Aging touches every living thing. Skin changes, strength fades, cells slow. But why aging happens the way it does remains unclear. Some point to DNA. Each time a cell divides, protective caps shorten until division stops. Others blame accumulated damage, tiny injuries that pile up over time. Another view sees aging as a trade-off. Evolution favors survival long enough to reproduce, not indefinite maintenance. And yet, nature offers exceptions. Some turtles show little decline. Certain jellyfish reset their life cycle entirely. Naked mole rats resist many diseases of age. Why do some creatures age slowly while humans do not? The answers remain elusive, but unlocking them could reshape medicine forever. The longest confirmed human life reached 122 years. Is that the limit, or simply an outlier? Some researchers believe there is a hard ceiling. Beyond a certain age, repair cannot keep up. Others argue there is no fixed maximum, only rising risk. What's puzzling is this: average life expectancy has soared, but the maximum has barely moved. Scientists search for clues in families of the very old in genes that resist diseased in drugs that slow aging in animals. Could humans one day live far longer? The data hints, but does not answer. The boundary of human lifespan remains hidden. Some creatures can rebuild themselves. A salamander regrows a limb, a starfish restores an arm. Certain worms regenerate an entire body from a fragment. Humans cannot. Why? In regenerative animals, cells near wounds revert to a flexible state, similar to early development. From there, tissues reform in perfect order. Humans share many of the same genes, but we do not activate them in the same way. If we could unlock this ability, damaged hearts could heal, spinal cords could repair, limbs could return. Despite decades of research, the blueprint remains incomplete. Regeneration remains a gift given to a few. Some creatures live far longer than expected. Greenland sharks glide beneath ice for centuries. Bowhead whales sing for over 200 years. Tiny naked mole rats outlive similar animals by a factor of 10. Each has its own strategy: better repair, slower metabolism, stronger defenses. No single solution explains them all. They remind us that aging is not fixed. It is a puzzle with many answers. Some animals survive being frozen solid. The wood frog's heart stops, its blood crystallizes, its body freezes. And yet, it awakens in spring. Sugars and antifreeze molecules protect cells, but how delicate organs survive months without activity is still unclear. If humans could do this, organ preservation would change. Space travel might follow. For now, the secret belongs to those who sleep in ice. Whales live long lives with little cancer. Despite their size and age, tumors are rare. This defies expectation. Elephants have extra tumor-fighting genes. Whales may have stronger repair systems we have not yet identified. If we understood this, cancer treatment could change entirely. For now, the answer drifts beneath the waves. Birds navigate using a sense we do not have. They cross continents with unerring precision, even when clouds hide the sun and stars. Some may sense tiny magnetic crystals, others may see magnetic fields as faint visual patterns. No single theory explains it fully. For birds, direction is written into the world itself, a hidden layer humans cannot perceive. And every autumn, monarch butterflies begin an impossible journey. Fragile wings carry them thousands of miles across generations. To the same forests. How they navigate remains unclear. A map we cannot read. A mystery carried on orange wings. What makes this journey so astonishing is that no single butterfly ever completes it. The monarchs that glide north in spring are not the same ones that left in autumn. They are generations removed, and yet, year after year, they arrive at the very same forest groves. Scientists know pieces of the story. Monarchs use the sun as a moving compass, adjusting their direction as the day passes. They may also sense Earth's magnetic field, feeling invisible lines beneath their wings. But one question remains unanswered. How is this knowledge passed on? How does a butterfly that has never made the journey know exactly where to go? It is one of the most breathtaking migrations on the planet, guided by a map no human has ever seen. Migration is written across the natural world. Salmon are born in quiet mountain streams. They swim to the open ocean, and years later, they return to the very same waters to spawn. Sea turtles crawl from the sea onto the exact beaches where they once hatched. Birds cross continents. Whales trace ancient routes through vast oceans. Insects ride winds across thousands of miles. Scientists have uncovered clues. Some animals follow the sun, the stars, or the tilt of Earth's axis. Others sense magnetic fields or subtle environmental signals we barely understand. Yet none of these explanations fully capture the precision. How does a bird find the same tree year after year? How does a turtle cross an entire ocean to one patch of sand? These journeys remain partly unexplained, guided by senses that lie beyond human perception. Migration is one of life's oldest rhythms, a silent dance carried in instinct. Homing pigeons carry this mystery into the sky. For centuries, humans have watched in wonder release a pigeon hundreds of miles from home. It rises, circles once, and then flies straight back. No map, no landmarks we can see, only a hidden sense of direction. Researchers have many theories. Some believe pigeons use the sun as a compass, correcting for time. Others suggest they sense Earth's magnetic field, like a living GPS. Some point to smell, proposing that pigeons follow invisible scent maps of familiar air. But none of these explanations fully explain their accuracy. Even under cloudy skies, even in unfamiliar places, they still find their way home. For pigeons, the world is filled with signals we cannot detect. For us, it remains an unsolved puzzle. No one knows exactly how humans first began to speak. Language defines us. Through it, we share ideas, tell stories, and build civilizations. Yet its origin is lost in deep time. Our closest relatives communicate with gestures and sounds, but none approach the complexity of human speech. At some point, our ancestors crossed a threshold from simple calls to words. Grammar. Abstract thought. How did it happen? Some believe language began with hand gestures, with spoken words emerging later. Others think rhythm came first, chants, songs, patterns of sound that slowly became speech. We find ancient art and symbols tens of thousands of years old, proof of minds capable of deep meaning. But the sounds themselves left no trace. Language allows us to speak of what is not here. Plan. Imagine. Dream. The first human words are gone forever, echoes we can only imagine. Laughter is universal, but its origin remains unclear. Babies laugh before they speak. Groups laugh together, spreading joy like a wave. Some scientists think laughter began as a signal of safety, a way to show that danger had passed, fear transformed into relief. Others trace it back to play among primates, breathy panting sounds during wrestling and chase. But laughter does more than signal survival. It lowers stress, strengthens bonds, floods the body with calm. Strangely, we laugh not only at jokes, we laugh at awkwardness, relief, even at sorrow. Why should a simple sound carry such power? We don't know. Laughter is ancient, shared by all humanity, its roots still hidden in our past. Music reaches places words cannot. A melody can bring tears. A rhythm can quicken the heart. A song can unlock memories long forgotten. Music has no clear survival function, yet it exists in every culture. Why? Some believe it bound early communities together. Others think it began as courtship. A signal of vitality and skill. Still others see it as a byproduct of language and memory. A beautiful accident of evolution. What makes music stranger is its power. People who cannot speak can still sing. Those with fading memories recall lyrics. Heartbeats can synchronize in shared rhythm. Why does organized sound touch us so deeply? Science has no final answer. Music remains an invisible thread, tying us together. Love shapes lives more than almost anything else. It binds parents and children, partners and friends. It inspires sacrifice, art, and devotion. Biology explains pieces, chemicals flood the brain, bonding forms. Evolution suggests love helped parents stay together long enough to raise children. But this is not the whole story. Why does love arrive suddenly? Why does it last a lifetime for some and fade for others? Love is not only chemistry, it is memory, story, meaning. We can trace its effects in the brain, but not its essence. Love remains one of the deepest mysteries of being alive. Humans cry tears of emotion. No other species does. Tears protect the eyes, but emotional tears appear with joy, grief, relief, and laughter. Why? Some believe tears signal vulnerability, drawing empathy from others, strengthening bonds. Others suggest tears release stress chemicals, though evidence is unclear. What deepens the mystery is contradiction. We cry for opposite feelings. Tears make invisible emotions visible. Yet why humans alone evolved this remains unknown. A secret carried in every falling tear. Across the world, myths repeat themselves. Floods, sky gods, tricksters, underworlds. Cultures separated by oceans tell similar stories. Why? Some believe the human mind is shaped for story. Certain themes arise naturally from shared fears and hopes. Others think myths spread through ancient migrations and trade. Still others suspect deeper patterns, symbols born from the same inner landscape. Whatever the cause, myths bind communities, carry wisdom, explain the unexplainable. Their strange repetition across the globe remains a mystery. Humans help strangers. This is rare in nature. We donate, volunteer, risk ourselves for people we may never meet. Evolution offers ideas, group survival, reciprocity. But humans go further. Even children help instinctively, before rules, before reward. Something draws us toward cooperation. Whether born of survival or something deeper remains unclear. It is one of humanity's most beautiful mysteries. Civilizations rise and fall. Again and again. The Maya, Rome, Mesopotamia. Climate, war, resources, corruption. Many explanations exist, none complete. What is striking is how sudden collapse can be: cities abandoned, knowledge lost. Civilization is fragile, and the forces that shape its fate are not fully understood. Curiosity drives us. We look at the stars, ask questions no other creature asks. Some say curiosity evolved for survival. Others see it as an advantage for invention. But curiosity goes beyond need. We study distant galaxies, ancient languages, questions with no practical answer. Children show it instinctively, reaching for the unknown. Why this hunger exists remains unclear. Curiosity shapes science and art, but its source remains hidden. Storytelling exists everywhere. Around fires, on screens, in books. Stories teach, entertain, bind communities. But they also do more. They make us care for people who never existed, live lives we will never live. Why do we need them? No one knows. Storytelling is as ancient as language itself, a thread connecting all cultures. And sometimes, nature reveals something even stranger. Lightning does not always strike. Sometimes, it floats. Glowing spheres drifting silently through the air, entering rooms, crossing fields. Ball lightning has been observed for centuries, and yet, no one knows exactly what it is. A final reminder that the world still holds mysteries, quiet, beautiful, unexplained. Sometimes, lightning does not strike. It lingers. Witnesses describe glowing spheres, about the size of a grapefruit, orange, white, blue. They drift silently through the air, lasting seconds, sometimes longer, before vanishing or ending with a soft pop. For centuries, these stories were dismissed as illusion, a trick of tired eyes during storms. But in recent years, credible reports, and even rare scientific recordings suggest something else. Ball lightning may be real. The problem is, no one knows what it is. Some theories imagine plasma held together by electromagnetic fields. Others suggest vaporized silicon glowing briefly after a lightning strike. Some propose chemical reactions sparked in the air. None explain every sighting. The mystery deepens when ball lightning appears indoors, floating through windows, passing through rooms, leaving glass unbroken. It behaves like matter and like light. Despite thousands of accounts, it remains elusive, unpredictable, unexplained. A ghostly fire drifting through history, one of nature's strangest wonders. Sometimes, the earth itself seems to glow. During powerful earthquakes, witnesses report strange lights in the sky, flickers along the ground, flashes above cities, orbs hovering near fault lines. These earthquake lights have been described for centuries, and now, cameras have captured them. They are real, but their cause remains unknown. One idea suggests that stressed rocks release electrical charges as the ground fractures. Another proposes that tectonic forces ionize gases near the surface, making them glow. But not every earthquake produces light, and no two displays look the same. In some cases, the lights appear before the ground begins to shake, raising the quiet question: could they be warnings? Their rarity makes them difficult to study, their unpredictability makes them haunting. Earthquake lights are among the most eerie of natural mysteries, brief flames in moments of chaos, hints that the earth carries secrets written in fire and stone. Volcanoes remind us that Earth is alive. Most eruptions are dramatic but familiar, flowing lava, ash drifting into the sky, the slow reshaping of land. But sometimes, a volcano erupts with unimaginable force. Enough power to darken skies, cool climates, change history. What turns silence into catastrophe? Scientists know pressure builds as magma rises. Gases expand, rock weakens. But the precise moment of failure remains hidden. Some volcanoes sleep for centuries, then awaken without warning. Others rumble for years and never explode. Events like Krakatoa in 1883, the Tambora in 1815, and the massive eruption of Toba 74,000 years ago released energy rivaling nuclear weapons. Toba may have nearly erased humanity. Yet even now, we cannot predict such eruptions with certainty. We measure tremors, scan magma chambers, analyze gases. Still, the deepest mechanics remain concealed. Volcanoes are reminders that Earth's power is patient and its mysteries unfinished. The surface of our planet is never still. Continents drift, mountains rise, oceans open and close, all driven by plate tectonics. Without it, Earth would be UN-recognizable, no earthquakes, no volcanoes, perhaps no life as we know it. Yet why plate tectonics began at all remains debated. Mars is quiet, Venus is locked, their crusts do not move. Somehow, Earth fractured into giant plates billions of years ago. Did water weaken rock, allowing it to slide? Did internal heat strike the perfect balance? Did ancient impacts crack the surface just enough? We don't know. Models compete, answers remain incomplete. And yet, plate tectonics regulates climate through the carbon cycle, it renews land, it stabilizes oceans. It may be the reason Earth is alive. And why Earth alone moves this way is still a puzzle. Water shapes every part of life. Oceans, rivers, clouds, every breath. But where did Earth's water come from? Some believe it arrived on asteroids and comets during the chaos of the early solar system. Many space rocks carry ice. Others suggest water was always here, locked deep in Earth's mantle, slowly rising to the surface over eons. Perhaps both are true. Some waterborne here, some delivered from space. What we know is this: Earth is unusual. Mars dried out, Venus lost its water. Something allowed Earth's oceans to remain. Every drop you drink carries an ancient question, a riddle as old as the planet itself. For most of human history, we saw only one face of the moon. The other remained hidden. When spacecraft finally revealed it, we were surprised. The near side is smooth, dark plains of ancient lava. The far side is rugged, cratered, almost untouched. Why should the same moon have two such different faces? Some suggest uneven heating from Earth long ago. Others propose an ancient collision reshaped one side. Differences in crust thickness or volcanic activity may play a role. But no explanation fits perfectly. The moon should be symmetrical. It is not. Even now, its hidden face holds secrets as if half of it still belongs to the unknown. Deep beneath your feet lies Earth's core. More than 3,000 kilometers down, a churning sea of molten iron and nickel. Its motion creates Earth's magnetic field, a shield against solar wind and cosmic radiation. Without it, our atmosphere might vanish, like Mars. Yet we cannot see the core, we cannot touch it. We study it through seismic waves, through magnetic patterns frozen in stone, through simulations. We know the outer core flows, we know this motion powers the geodynamo. But why the field weakens, why it wanders, why it reverses, remains uncertain. Other planets deepen the mystery. Mars once had a magnetic field, then lost it. Why did Earth keep its shield? The planet's beating heart remains hidden, felt, but never seen. From time to time, Earth's magnetic poles flip. North becomes south, south becomes north. Rocks record these reversals like a barcode through time. The last full flip occurred about 780,000 years ago. Why do they happen? Turbulence in the liquid core may destabilize the field, causing it to collapse and rebuild reversed. But the trigger remains unclear. Sometimes reversals are fast, sometimes they take thousands of years, sometimes the field weakens, but never flips. What would such a weakening mean for life? Did past reversals shape evolution? We don't know. One day, the poles will switch again, and the reason will still lie deep below. Earth's climate has never stood still. Ice ages come, ice ages go. Glacier advance, then retreat. These cycles shaped landscapes and human history. Some explanations focus on subtle changes in Earth's orbit and tilt. Others point to volcanoes, ocean currents, carbon feedback loops. Likely, all of these intertwine. But the engine behind the rhythm remains debated. What is clear is this: climate is not fixed, it is part of a long, mysterious cycle. Life has nearly ended before. 5 times, mass extinctions swept the planet. The dinosaurs' end is famous, but earlier disasters were even greater. Asteroids, supervolcanoes, climate collapse, poisoned oceans. Sometimes the cause is clear. Often, it is not. Why some species vanish while others survive remains unclear. Each extinction cleared the way for new life. Destruction, followed by renewal. A reminder of fragility and resilience. Saturn wears rings of light. Vast, brilliant, almost impossibly thin. For centuries, we believed they were ancient. But recent evidence suggests otherwise. The rings appear young, too clean, too bright. If they were billions of years old, they should be darkened by dust. Data from the Cassini spacecraft hints they may be only hundreds of millions of years old. A cosmic moment. How did they form? A shattered moon? A broken comet? No answer is certain. And they may not last. One day, Saturn's rings will fade. We are living in the brief era when the giant planet wears its crown. Uranus drifts through space on its side. Its axis tilted nearly 98 degrees. For decades, One pole faces the sun, the other rests in darkness. How did this happen? A massive ancient impact, multiple smaller collisions, gravitational tugs in the early solar system? Each theory leaves questions. Uranus is unique. Its seasons are extreme, its magnetic field oddly tilted and offset. A planet turned sideways, with no final explanation. No spacecraft has returned to Uranus since Voyager 2 passed by in the 1980s, but that brief encounter remains our only close look. Since then, the planet has rolled onward, quietly turning on its side, carrying a mystery no other world shares. Until we return, Uranus keeps its secret, a tilted riddle drifting through the dark. Venus looks familiar, and yet it is deeply strange. Nearly Earth's twin in size and mass, Venus hides a very different history point. One of its most unsettling traits is its rotation. While most planets spin in the same direction they orbit the Sun, Venus turns the opposite way. On Venus, the Sun would rise in the west and set in the east. Stranger still, a single day on Venus lasts longer than its entire year. How did this happen? Some scientists believe a massive early collision flipped the planet's spin. Others suggest slow tidal forces from the Sun gradually reversed it over time. Another idea imagines Venus once spinning like Earth, only to be slowed and reshaped by its dense atmosphere and internal forces. None fully explain the world we see today. Beneath thick clouds of carbon dioxide and sulfuric acid, Venus turns slowly backward at a planet that looks familiar, yet moves against expectation. Far beyond Earth, Neptune is alive with storms. At the edge of the solar system, winds scream across the planet at nearly 2,000 kilometers per hour, faster than anything known on Earth. Dark storms rise and fade in Neptune's deep blue atmosphere. The most famous, the Great Dark Spot, was seen by Voyager 2 in 1989 at a storm as wide as Earth itself. When astronomers looked again years later, it was gone. Other dark spots have appeared since, drifting, breaking apart, disappearing without warning. Why does Neptune rage so fiercely, despite receiving so little sunlight? Some believe heat from deep within the planet powers the chaos. Others think subtle atmospheric dynamics amplify small changes into massive tempests. The truth remains unclear. Neptune has been visited by only one spacecraft. Its storms remind us that even in the coldest reaches of the solar system, turbulence can thrive. High above Jupiter's clouds, a crimson storm has raged for centuries. The Great Red Spot has been observed for at least 350 years, perhaps far longer. Large enough to swallow Earth whole, it spins endlessly in Jupiter's southern hemisphere, an anticyclone fed by a vast and restless atmosphere. But even giants can change. In recent decades, the storm has been shrinking. Once wide enough to fit 3 Earths across, it has narrowed dramatically. Why did it form where it did? Why has it survived when storms on Earth fade in days? And will it vanish, or renew itself in cycles we don't yet understand? The Great Red Spot is both ancient and fragile, but a reminder that even long-lived wonders are not guaranteed forever. Comets arrive like messengers from the dark. They sweep in from distant reaches, glow near the sun, then vanish again into the cold. Astronomers believe they come from a vast reservoir far beyond Pluto. The Oort cloud, a spherical shell of icy remnants left over from the birth of the solar system, trillions of objects drifting at the edge of interstellar space. And yet, no one has ever seen it directly. Its objects are too small, too distant, too faint. We know the cloud only by the visitors it sends us. Was it shaped by early planetary chaos? Does it extend farther than we imagine? The Oort cloud remains unseen, a ghostly frontier surrounding our solar system. Beyond Earth, water hides in unexpected places. Moons like Europa, Enceladus, and Titan conceal vast oceans beneath their frozen shells. Some may hold more water than all of Earth's oceans combined. Tidal forces from their parent planets need their interiors, generating heat, enough to keep liquid seas alive in the dark. Where water exists, life often follows. On Earth, hydrothermal vents thrive without sunlight. Could similar ecosystems exist beneath alien ice? We have hints. Enceladus sprays water into space, rich with organic molecules. Europa's cracked surface suggests movement below. But we cannot yet see into these oceans. What swims there, if anything at all, remains unknown. Enceladus is small, bright, seemingly quiet. And yet, it erupts. Jets of water burst from fractures near its south pole, launching plumes into space. Cassini flew through them, tasting salts, organics, and signs of chemical energy. Beneath the ice lies a global ocean. Are these plumes driven by hydrothermal vents, like those on Earth's ocean floors, or by processes we don't yet understand? Enceladus offers something rare: a direct window into a hidden sea. But until we return, what stirs below its ice remains unanswered. Titan feels strangely familiar and utterly alien. It has rivers, lakes, and seas. Rain falls from its skies. But instead of water, the liquid is methane. Here lies the puzzle. Methane should be destroyed by sunlight over time, yet Titan seas persist. Something replenishes them. Cryovolcanoes, hidden chemistry, or something more unusual. Methane can be a sign of life. Titan's methane cycle mirrors Earth's water cycle in eerie ways, but the source that sustains it remains hidden. A quiet engine beneath an orange sky. Mars once flowed with water. River valleys scar its surface. Ancient deltas and lake beds lie frozen in time. Long ago, Mars may have had oceans. Now, it is dry, cold, thin-aired. Where did the water go? Some is locked as ice, some trapped in minerals. Much may have escaped into space when Mars lost its magnetic shield. But the full story is incomplete. Did the water vanish slowly, or disappear in sudden shifts? Could liquid water still move underground today? The fate of Mars's rivers is tied to a deeper question: whether the planet once supported life, and whether it still might. Mathematics lives on paper, yet it governs reality. Equations written by human minds describe stars, atoms, and galaxies with astonishing precision. Black holes predicted before they were seen. Radio waves described before they were detected. Why should abstract symbols map onto the universe so perfectly? Some say mathematics is discovered, not invented, a hidden structure waiting to be revealed. Others believe it is shaped by the human mind, tuned to patterns we evolved to see. Neither answer fully explains its power. Why should the same equations describe a falling apple and the motion of distant planets? Mathematics is both human and cosmic, and why it works so well remains one of existence's deepest mysteries. The universe runs on numbers. Constants fixed with extraordinary precision: the speed of light, the strength of gravity, the charge of an electron. Change them slightly, and stars may never form. Life may never arise. Why do these values exist at all? No theory explains them. Some imagine countless universes, each with different settings, that we simply live in one where life is possible. Others see pure chance. The constants are like dials set long ago that we can measure them but not explain them. Randomness seems obvious. A coin flips, dice roll. But physics complicates the picture. At the quantum level, events appear unpredictable, particles appear and vanish, atoms decay without warning. Is this true randomness, or hidden order beyond our reach? Einstein believed deeper laws must exist, yet experiments suggest randomness may be fundamental. If so, uncertainty is not ignorance, it is reality. Whether the universe is ordered at its core or truly random remains unresolved. We live inside time. We feel it flow, past to future, moment by moment. But science cannot fully explain what time is. Einstein showed that time bends, stretches, slows. Clocks tick differently depending on speed and gravity. Yet we experience time as one-directional. Why does it move forward? Entropy may explain part of it, but that only raises another question. Why did the universe begin in such order? Perhaps time itself is an illusion, a construct of perception. Time shapes every life, yet its true nature remains elusive. Matter exists. Antimatter almost does not. At the universe's birth, both should have formed equally and annihilated each other completely. But something tipped the balance. Matter won. Tiny asymmetries appear in experiments, but not enough to fully explain existence itself. Why anything remains at all is still unknown. And without that imbalance, there would be no stars, no planets, no one listening now. Somewhere beyond what we can measure, the universe keeps its unanswered questions. Not as puzzles to be solved, but as quiet companions drifting through time. There are worlds no spacecraft has touched. Motions no equation can fully capture. Planets that turn against expectation, storms that have endured longer than human history, oceans hidden beneath ice, sealed away in darkness. These mysteries don't demand your attention. They don't ask to be understood tonight. They simply exist. Like distant stars you don't need to name, like patterns you don't need to follow. As you listen, it's enough to let the unknown remain unknown. To allow unanswered questions to soften, to lose their sharp edges, to become part of the background hum of the cosmos. You don't have to stay awake for what comes next. You don't have to hold on to every thought. Let the mysteries pass through you slowly, like light traveling for millions of years, arriving gently and then fading. The universe is full of things we don't yet understand. And somehow, that makes it calmer, not louder. You've just drifted through some of science's deepest unanswered questions. Mysteries that stretch from the smallest workings inside your body to the farthest reaches of space itself. Each one is a quiet reminder that no matter how much we learn, the universe remains wider, stranger, and more gentle than certainty alone could ever be. Think of what passed by tonight. The fragile spark of awareness that lets us wonder at all. The slow puzzles of memory and time. Hidden oceans beneath frozen moons. Ancient storms, silent stars, and the unseen structure holding reality together. Some of these questions may one day find answers. Others may wait far beyond our lifetimes. And some may never be solved at all. But that is not a failure. It is part of the beauty. To live in a universe that still holds mystery is to live in a universe that is not finished, not closed, not done revealing itself. Every unknown is a doorway left open. Every unanswered question, a soft invitation rather than a demand. And now, as you rest here, notice how these mysteries no longer feel heavy. They don't press for solutions. They don't ask you to stay awake. They move slowly, like waves repeating the same calm rhythm on a distant shore. Steady, predictable, soothing. You don't need answers tonight. You only need rest. Let your breathing settle into its own gentle pattern. Let your body sink, loose and warm. Let your thoughts blur at the edges. Imagine yourself drifting through what we explored, passing mysteries like constellations scattered across a dark sky. Questions above you, questions below, wonder everywhere. And you, quietly floating at the center, safe in the knowledge that mystery is not something to fear, but something to rest within. If you're still awake, another story will be waiting when you're ready. But for now, there is nothing left to do. No answers to chase. No puzzles to solve. Only the soft certainty that mystery itself can be a lullaby. And it's already carrying you toward sleep. Good night. And may your dreams remain gentle, wide, and full of quiet wonder.